update for Winter Storm Scott, and there will be a severe weather outbreak in the southeast tomorrow. I just saw the discussion. It looks like the main threat is what I thought it would be when I was talking with David. It's going to be hail, some damaging winds, and a few isolated tornadoes. I don't think there's going to be a tornado outbreak, as any of those supercells are not going to be along the line, but actually on those isolated, discrete supercells that form ahead of the line. That's what the severe weather discussion I just read uh, said, and that's what I thought basically. Usually, when you have tornadoes, they're always ahead of squall lines, not usually along them. You could get tornadoes on squall lines too, but it's more common to get tornadoes on isolated supercells, or if you have a kink in the line, which will cause the storm to rotate. Like if you have a bow echo, sometimes on the northern edge of the bow echo, where you have a kink in the line, you could get a spin up there and have a brief tornado. That happened in New York City on September 16, 2010. But that's fairly unusual. Let's look at this model here. This shows a pretty accurate description of what's going to happen tomorrow. Shows snow coming into the city around between 5 and 6 p.m. Actually, between so this is 20. This is between 4 and 5 p.m. Snow's coming into the city. So by 5 p.m., snow should be just starting in the city, becoming very heavily. This is becoming heavy snow by around 11 p.m. and then snow should be ending in the city, just starting to end around 7 a.m. So let's look at this run now. So showing that, but wow, this one is showing a stronger storm. Look at that, 1,004. This one is showing 1,006. Let's go to hour 35, or about hour 32, which would be hour 28 here, 26. See 1,003, and look at that, yellows now. This looks a little bit more impressive, if you ask me. Going to 18Z here, also 1,003. So the strength is about the same, but it's more compact. I mean, this low is a little bit more compact. And let's see, does it extend further west? Yes, it does, just a little bit. Let's go to 2 more hours out. Oh, 1,000 millibar. So up here, 994 still here. So there's it's still lingering. That's what's a little unusual. Okay, if you have a low pressure system here, right? Normally, you would have a lot more precipitation on the west side, especially if the storm is like firing itself up. So this could be a little bit underdone, possibly. Could be wrong, but I do believe this is underdone slightly. I'm going to go to the HRRR on the weather.cod site just to see what the site is saying. Okay, Mid-Atlantic. See that will show me the low pressure system. Looks like 1,006 here. Go to 0Z here. This will be our, this 1, 2, 3. So this will be, so it's a little bit more long. It's a little bit more impressive here. Let's look at total precipitation accumulation for the midnight run. So it looks like, I would say, actually you should get between 0.5 and 0.7 ppf, which would equal to between 6 to 8 inches of snow. Let's look at that snowfall. But usually Kohara method is more accurate. That's looking at 10,000 feet, where most of the snow does form. Look at that, look on Long Island, I get over 6 inches. And looking at the coherence, oh, sorry, that's not what I want to look at. And looking at the total coherent accumulation, which is actually more accurate. You want to look at snowfall. It shows a little bit less. But this actually may be a bit more accurate. However, I'm going to look at the not just the GFS, but the SREF as well. The 3Z should be coming in now. Well, actually, it's still 21Z. Yes, the SREF usually comes in actually on the hour. So I'll have to wait until 2 a.m. to get the SREF. So let's look at the European, today's run of the Euro. Look at that, it shows a 992 right off of southeastern Massachusetts. Let's look at the ensembles of the Euro. Let's look at lower dynamics, go to mean surface level pressure anomaly for it to load. And basically this will show if there's any disagreement or if most of the operation has a stronger system. Look, 993. So we could be, so basically this is implying the storm could be anything from like 988 to 995 millibars, so around that range. Here's what the operational is showing. But you do see how wide this is, right? But you see the center isn't here, but it's up here. So this could be a bit stronger or a bit weaker. However, this one from last night had basically a weaker system. And it passed by something like this. And looks like we're not going to get any more snowstorms according to this run. So let's look at going out here. Possible something. Let's look at the mesoscale here. And it looks like RGM models. Still waiting for it to load again. So looking at the severe weather threat for tomorrow in the southeast. Alrighty, let's go to simulated reflectivity. All right, still waiting for the RGM to load. That's a very heavy snow. Look at that, right there. Very heavy snowfall rates there. This one is saying 8 a.m. ending. I think that's pretty accurate. Total precipitation accumulation. 1, level 2 QPFs. A bit more than 3/4 of an inch. Let's look at snowfall. Hopefully it's between 8 and 10 inches, something like that. Yep, about right. Definitely winter storm warning criteria. See if there's any other models to look at. I think that was that. Yeah, I already looked at it. HRDPS. Look at that. Here you have an already 996 right in there. So you're already getting a pretty strong system developing. That's what doesn't make any sense. If you're having such a rapidly intensifying system, wouldn't there be more precip on the west side? That's just what's a little bit confusing here. And also it's moving very fast. And then it slows down around this time. That's a little bit unusual. But of course, the jet stream is what's really pushing it along. Look at that. kind of like a bit of a push for the storm here. Look at that right there. So look at that. That's going to be actually rain and snow mix there. Let's look at that here. See, right on the line between rain and snow. New York City's right on that rain snow line at that time. So only about 10 inches of snow. New York City is right on that line. And let's look at Icon. This is another pretty good model to look at. I'm going to go to 18Z. I'm going to compare the previous run to the current run. And I just want to see if it's showing a weaker or stronger system. I think 1002 this time. About 12 hours of snow, or we had quick hitting, falling overnight hours, ending early in the morning, just like the last storm. The last storm actually started in the late evening. This one's going to start in the mid-afternoon and end early in the mornings. So I'll say this storm's going to last maybe 2 or 3 more hours than the previous storm. Even though it's covering so much more area, it's just moving so fast, basically. You see, this one is even showing a weaker low pressure system than the last one. So, but this is one of the models. So just let's look here. 995, right here, 999 millibar low, right over the North Carolina Virginia border, right around the Tidewater area. So it's kind of still backed up a little bit. Let's look here. 996, 993, and then shooting out of here. So this looks like about I would say a 5 to 7 inch event. No, not even 4 to 6 inches. I mean, this is the Icon model. This is just one run. Look at that. Showing very little. So that probably is not very reliable. Let's look at the NAM3. Okay, we already looked at the NAM. We already looked at most of the models here. So basically, it's safe to say that there's going to be a severe weather outbreak here. Look at that for tomorrow. Here are these. There's where you could have some tornadoes. These discrete supercells. Right here, boom, discrete supercell right there. See, they're forming ahead of the line. This is where you'll have the tornadoes, right in this area. Tornadic supercell, some embedded supercells in the line. Definitely, that's a possibility. See, and then they'll become part of the line. But before they become part of the line, they could be producing tornadoes. And let's look at updraft helicity. Updraft helicity swaths. Let's look at those. Ooh, pretty intense. So tomorrow definitely looks like a pretty bad day, especially for the southeast. Well, we're just going to be getting snow in New York City. This is much more of a threat. So let's look at the models now ahead. Looking into the future now. Got some snow for tomorrow. Then another storm system coming into California. More rain for San Francisco. Coastal event that's going to be way off the coast. No threat for us here in the Northeast. And then maybe some light snow next weekend. Very little, maybe a couple inches. And rain for Sunday. So you're going to have snow Saturday, then rain on Sunday afternoon, and then another cool down This looks to be about right. Okay. Let's look at the GFS MV3 again. Just want to make sure I got everything here. There we go. About 8 inches. Let's look at the New York City area here. So, let's look at surface precipitation. This is right now. Oh, Denver's getting some pretty heavy snows now. Let's look at Denver. Denver's getting so 7 degrees Fahrenheit, or at least it feels like it's 7. No, this is an actual temperature of 7 right now. That's the high, that's the low. And winter weather advisories in effect. So snow early, about 2 inches. Let's look at their weather for today. Today, their high was about, let's say, 30 degrees today. 31 was their high. Look at that, light snow started around 1:49 p.m. It's been snowing there for the past 6 hours. And look at this temperature just falling. 25, and it fell all the way through the single digits. And look at the humidity. I mean, just look at this humidity. It's humid. Even though it's so cold, look at the humidity, 98%. Very humid for such cold temperatures. I don't think I've seen it so humid and cold. Like, this usually happens at night when the winds are very light. But this is with snowfall coming down. So this is a very humid and very cold atmosphere. So if there's any low clouds in addition to the snow, there's probably going to be some line frost as well, or some freezing fog in addition to the snow. This is pretty impressive, if you ask me. These definitely showing this. Ooh, it's getting really cold tonight in Denver. It's like say a low of yeah, definitely close to 0 there in Denver. It looks like some areas might get as cold as negative 28 degrees. But tomorrow afternoon, for that, it'll moderate all the way to the low single digits, with the coldest temperatures being across Minnesota. Oh, never mind. Around 0 will be the coldest temps. This storm for tomorrow. This is the storm for tomorrow. It's all the way in Colorado, so this is moving like really fast. This is what I call an express, just zipping right along. You know, sometimes storms will take days just to get from here to here. It would take like 3 or 4 days. This is just doing it in a few hours. Wow, that's fast. That's really fast. This is one unusual thing about this storm, is how fast it's moving. Oh, I'm a little tired right now. Yeah, it's moving really fast. So my forecast for the city is between 6 and 9 inches at the moment. Might give or take a few inches, but looks like safe bet of 8 to 9 inches. I've checked almost every single model there is to check. Only thing left to do now is to wait, watch, and wait for tomorrow. What's going to happen? So I'm going to continue this live stream for the time being. And just going to look at other models. Let's look at I'm going to change gears and talk about, well, earthquakes. I'm going to go to the USGS, just talk about some earthquake activities. Earthquake activity has been occurring recently. See if there's anything interesting. Oh, that's the normal. This little, that's not a swarm. That's very normal. That's because of the the hydrothermal activity, the hydrothermal plant. So that's just from the motion of the hydrothermal hydrothermal fluids. This is not volcanic, but there is a volcanic field here. This is what's generating the hot, the geysers. It's the volcanic field here, and they're using the heat from this volcanic field to generate the geothermal plant here, which is generating the earthquakes. Um, Looks like it's pretty quiet here in Northwest. One quake here right around Rainier. This is Mount Rainier, 0.7. Let's look at the past week. Just one quake. And Mount St. Helens had a quake. So nothing unusual. There's also always a swarm seeming to go on here. There's a small little fault that runs through this area. Small strike slip fault. And let's look at Japan, where they look at the last. Look at Hawaii. Looks like there was a little bit of a swarm going on here, and close to Mauna Loa. Mauna Kea. There's a small swarm going close to Mauna Loa, and the one near the volcano itself, Kilauea. This is where Mauna Kea is, on the north side of the island. But at the moment, nothing seems out of the ordinary. Let's go back to 30 days, 4.5 plus. Or let's go to significant earthquakes. There was a 7.5 which occurred on the 22nd, just a week ago, and a 7.0 which occurred just a few days, just yesterday. Both of these quakes were very deep, 257 kilometers and 132.4 kilometers respectively, so very deep quakes. So 3.1 is considered, significant for some reason. Yet, how is a 3.1 considered significant when here there's a 4.9? Not considered significant, maybe because this is for the United States. This is right on the Mid-Atlantic Ridge in kilometers, which means they don't know the depth, so they always put 10 km when they're not sure how deep it is. So, small subduction zone quake, 14.8 kilometers deep. Actually, this might be a strike slip. Here's the subduction zone quake. The subduction zones here. This is a subduction zone. This is another subduction zone because you have volcanoes here too. You have two subduction zones. One running parallel here, and I think this goes from being a subduction zone to being a strike slip. There's a fall that runs right through eastern Siberia. I don't know what the name of that fall there is. Siberian fault. Baikal Rift Zone. Yeah, it's a rift zone, basically. That's the Baikal Rift Zone. East Russia's fault line. What's that? What fault line would run through that area? I'm going to go back to weather. I just want to see, because this is talking about weather and earthquakes. So, any of you are interested in this, you're welcome to stay on. Let's see. This is taking a very long time. Looks like Slotnayo, and Pagana, and Suzuman. The fault line would run basically through Shaklan Island, and then go through the Sea of Okhotsk and go north into Siberia or eastern Russia. This is where the fault would run through. Jacqueline Island Fault. Shackle Hokkaido Fault. Strike slip. Let's see. Yeah, let's look here. So it's called the Okhotsk Plate. In the south and west. Here is the Okhotsk Plate right here. Okhotsk Plate right here. There we go. These are a bunch of strike slip faults right here. Transform. This is a subduction zone right here. This is where the two subduction zones converge, right here. This is where you have basically double subduction almost. Right in that area. That's eruption 1.5 million years ago. Oh, there it is. Who's on here is a volcano. Okay, let's switch fields and go back to the talking about the storm. By the way, this is the Canadian here. And this is looking at, yeah, I think this is an old, yeah, this is looking at way back then, February. Yep. Okay, let's go to tidbits again. Let's go back to the HRRR. Should be just starting to upload or update itself. My YouTube, yep, live. Good, I'm streaming. Oh, let's see. It says one watching right now. If you want to just drop a few comments, I know I'm disorganized right now. I've been having a lot of problems with this, trying to set the stream up. So, yeah. Because last time I tried to create it was really easy. Just Google, Google Hangouts. This time I had to do some maneuvering to get it done because they're saying they're going to take Google Hangouts away, which it's going to make it a lot more difficult to stream now. Now like that, I can't really record the screen. I have to be using different software. That's just going to make things a lot harder. I'm going to close out a lot of these windows here, and oh wow! Look at all this lightning. This is probably from earlier. Well, and okay, done. Let's look at the HRRR again. It looks like it's just starting to upload. Okay, looking at the hour going. Let's look at the minute. Let's look at the southeast. Okay. Hey.
I'm talking to my friend right now.
Oh.
Bad. Yeah, I'm really. Can I get a break for not talking to anyone for a while?
Sorry, David. Sorry. Yeah, I'm really sorry.
I've been talking since like 3 o'clock this afternoon.
Yeah, that's 6 hours. Wow. Yeah, I'm sorry. Yeah, I have nobody on my live stream. I just want people to join my live stream. I got nobody.
Oh, I crap, I forgot about it.
Yeah, I just wanted to remind you. It's okay.
Let me see.
Yeah, I'm actually live right now. Trying to talk about tomorrow's severe weather event. Let's look at, so looking at the models right now. So here's the low pressure system that's going to start forming tomorrow. Well, it's starting just to form. It's hour 8 now.
I'm watching your live stream right now.
Thank you, David. So here's our.
Okay, talk to you later.
Okay, talk to you later. This is hour 8 right here. See that little 1012 low? Let's go previous run and see what it looked like. About the same. This coverage is a little smaller. Is this going to be what is going to become the storm? Looks like it is. So looks like this is showing a weaker system now. Let's look at simulated reflectivity. It's showing more or less precipitation than the previous run. And it looks like more or less about the same. Let's look at hour 3. This is going hour 10 now. Still showing 1012. So 1012. Let's compare the coverage. Yeah, it's showing a slight decrease in its size. So let's compare this to the midnight one, though. So so it is showing a stronger system, though, compared to the midnight run. And if the midnight run is showing about half an inch of QPF in New York City, maybe that's how much we're gonna get. I'm gonna be ending this live stream in about 20 minutes. You know, because I've had some trouble starting this stream because I'm doing it via Google Hangouts. And I'm gonna go to the live stream right now itself. Go to Storm. Go to my page right now. Let's see how many people are watching this stream. So yeah, the storm for tomorrow looks to be pretty impressive. So let's look at the storm for tomorrow. Looks like, well, looks pretty impressive. Look at these highs here in mid to upper 70s. So definitely some severe weather is possible here in the southeast tomorrow. Definitely. So go to the northeast. Go to the northeast. I will be mid-Atlantic, sorry. There we go, mid-Atlantic. And I will be making a video just for the sake of making a video. You know, not a stream, but let's look at this. 1,000 millibars. Let's see how much QPF this shows, total precipitation accumulation. I believe around, I would say, just a little bit around a half an inch QPF in New York. Yep, half an inch. So not too much, not too little. And let's look at snowfall here. I'm gonna stay up for 2 more hours. I'm gonna go to bed around 3. So the stream will still be going. I might pause the stream for temporarily if I can. Looks like I can because I'll have to stop the broadcast, which means the stream will end. And I do not want to end the stream, so but I don't want to keep the stream going on for too long. I guess I'll just stop this stream and then do another one later. Once the 6Z run of the the 6Z run of the HRRR comes in is when I will restart or start a new stream. But let's go back to the let's go back to the other models. Go to HDRPS. Optical tidbits. And then I could, here are the forecast models. And let's look at the WRF model. Alrighty, so it's still kind of taking its time. Still showing a 12Z. All right, I already saw the RGM. Let's look at the NAM 12cam, but I already saw the NAM, so I pretty much have a general idea what's going to happen. Let's look. Here's a storm coming in. Here's a storm that it came onshore California earlier today, and now this storm is gonna transfer its energy because it went over the Rockies to the Gulf Coast, to the Gulf states, and then that will go up the coast. This one is showing a strong system, but almost no precipitation on its northwest side, which is very unusual. Usually with such an intense system, you usually find a pretty good amount of precip here. That's what's so unusual. Look at this. This is a little bit unusual. This right here, this what looks to be a dry slot almost, but that's pretty unusual if you ask me. First of all, most of the precip in this case is on the north and east side of the storm, and not on the north and west side as typically you would find, especially as the storm is developing. See, it's 1,001 here, and then it's 988 here. So this is usually you would find precipitation forming on the west side of the storm and on the north side. Not so much on the east side. This is pretty unusual, especially for a storm that's moving southwest to northeast. Because in 6 hours, it's going to be going from South Carolina, just 6 hours, to be over Virginia. I mean, this is moving fast. This is moving like 60, 70 miles an hour. Total precipitation accumulation, it shows about. This is why it's showing so little. I mean, this one was moving at least at a normal speed. This one could be producing a lot of snow, but it's not because of how fast it's moving. This is a very fast-moving system. It's a pretty potent storm, but it's moving so darn fast, we're going to get hardly any accumulation. So let's look at the Canadian. I mean, this is going to be, this is a 6 hour run thing. So let's look here. It'll probably be in North Carolina in the next an hour 24. So boom, boom, boom. See, also kind of doesn't make sense here. Yeah, the NAM is definitely off when it comes in terms of the snowfall. I mean, the Canadian, pretty off. It's definitely going to be off with snowfall. Maybe not so much. I think the Canadian actually got it pretty well. It's just that how fast it's moving. Look at this. In 12Z, they're already showing the snow ending pretty much. Looking at 12Z. This is more likely here. Here. I think the 12Z is actually more likely. And based on the 12Z, I think a forecast of 8 to 10 inches is definitely likely for the city of New York. And look at what happened in Nova Scotia earlier today. They really got walloped, especially on the south side. They got hit really hard. Stream is still going on. So let's see what's going on here. Okay, my forecast is calling for 8 to 12 inches of snow. Well, actually, not 8 to 12 inches. I'm cutting it down to 6 to 9 inches for the city. 8 to 12 will actually be north and west of the city. So let's go way out. This is very unlikely. So, this is. Let's see if the WRF has finally updated. Still has not updated the midnight run. It's already 12 a.m. and it still hasn't updated. This is what was shown earlier today. This is when the severe weather threat's going to start. It looks like about between 0.5 and close to 1 QPF. See here, one layer here, one layer here. So not too much. It's like a snowfall here between 6 and 8 inches. Closer to 10 for the DC area, just north of DC. So let's look at just one model. Let's look at WRF ARW2. This is another run for one of the different models. So let's look here. Let's look at hour 33 here. You get 1,004 millibar storm here. Look how far the storm is. Look how far the precipitation extends north. This is looking at midnight run yesterday, by the way. 1,005. So kind of the same thing. And this is looking at last night earlier. Okay, this is actually looking at today's run. Yeah, I think the difference is here. It's kind of far north, the center of the storm. Let's look at total accumulation now. Yep. Not too much snowfall here. Yeah. Looks like about, I'll say, 47 based on these 4 runs. Let's look at let's look at lower dynamics. And let's look at the based on this on WRF NMM. I don't know what that stands for, but I think it's look at this is the storm from earlier today. And look at the storm that hit Nova Scotia today. Big snows there today. Nova Scotia storm. Nova Scotia storm. Yep. And what's the one they talking about? Is it this one or the one that's gonna, or are they talking about the one that just hit, or the one that's coming up for them? Let's check the stream. Can't really. Saying. That's a little unusual again. That's again unusual. Let's look at total precipitation accumulation. And let's look at whether that Kali DDU again. Let's see. It's 10,006 here. Let's go to hour 15. Hour 3 here. About all the same. Well, look at that 1,004. That 1,006. Kind of small here. Oh, it's a little bigger, so look at this. 18Z. And this is hour 18. Let's go here. Have a, oops, that's going to be hour, that's hour 22 here. 6,004. Might be getting a stronger system. I don't know about the snowfall though, but let's look at simulated reflectivity. Severe weather again. Look at that. This is where you're going to be having some tornadoes right here. Boom. To the thunderstorms, here, thunderstorms. So there we go. Here we're going to have a dramatic storm right here. That's a rotating thunderstorm there. And according to the Mid-Atlantic area, whoa, that is here. But it's moving so fast. Look at this. Hour 20. Wow, that's some fast moving stuff. Go to the Atlantic again. Yeah, I'm having some issues right now with this site. Let's look at snowfall here. This is where the center of the storm is right here. Ethan tried to say it's going to go like that. And this being the center of low right here, and it being right in this general area. Ah, so yes, it is kind of far north. Maybe this model isn't that wrong. I'm saying it's going to, like on the northwest side, you're not going to have much precip. So thank you for watching. I'm going to end the live stream now, and I'll resume it later. Thank you for watching.